Yeah? Okay, good. All right. Okay. So these are the assumptions if you want to do hypothesis testing. Okay. Usually in data mining, we don't care about hypothesis testing very much. Okay. In classical statistics, hypothesis testing is everything. So these are the assumptions that you have to make if that's what you want. Okay. And then, of course, you check the p-value. I already talked about the p-value being the key. Anything less than 5% means the model is good. The variable is good in the model, and so on. Okay. So I already discussed all that here. So this is just simply, I don't know why there is a repeat here. So it's the same thing from here. So that means slope is not 0. So these are the 3 predictors, right? And the p-values are these. So conclusion is significant. That's what you would say. They're significant. Those variables are significant. Now, interpreting slopes, okay, so here we have to go back to this. Okay. How do you interpret the slopes? Okay, I'm going to copy paste the slopes here so we can see. So for fuel type, we have 2 of them, right? So the fuel type slope is that. Okay. Then we have fuel type petrol is that. Okay. So let's try to interpret these 2, and then we will look at weight and kilometer. Okay. Now remember, we're going to leave one of the categories out, right? So here we had 3, we left 1 out. We defined dummy variables only for 2. And if we have 15 dummy variables, 15 categories, we will leave 1, we'll have 14, right? So the one that we leave out is the basis, okay? So these coefficients compare what happens to y, what happens to our target variable relative to the category that we left out. So here the category we left out is compressed natural gas, CNG. So compared to CNG, what is this particular category? What does it do to target? Target is what? Price. Price, okay? So compared to CNG, okay, if you have a diesel car, what's going to happen to the price? That's what's going to happen to the price. So that's what the slope says, which is what? It says minus 709. So that means compared to CNG, a diesel car will cost you $709 less. So that's what it says. So it means, why are we comparing it with CNG? Because CNG is the one that we left out without defining a dummy variable. So compared to CNG vehicle, right? Diesel vehicle price will be $709 less, with all other variables being the same. Okay. So you have other variables, so we have to hold all the other variables the same. Same weight, same kilometers. Okay. Now the only thing that's changing is compared to CNG, what is diesel? So now for fuel type petrol, same thing. Okay. Again, we are comparing to the one that was left out, which is CNG. Petrol vehicle's price will be, again, this is the negative value, so you said $284 less, with all other variables being the same. Okay. Now we have weight and kilometers. So here these two are regular variables, so there is nothing to compare here. So weight is that, and kilometer is that. So once again, what we are trying to say is if these are slopes. Remember, slope is what? If in 2 dimensions, it will be rise over run, right? So when x goes up, what happens to y? So here x is weight. If weight goes up by 1 unit, what happens to the target? Target is what? The target is price. So if weight goes up by 1, and here the weight is in kilograms. Okay, you remember this is European data set. Okay, so if weight goes up by 1 kilogram, what price for this data set? Price, because it's a positive value, so price goes up by $35. Okay. I don't know why it's not euros, but it's in dollars. Okay, so for an increase of, well, you can probably say this better than I can. For an increase of 1 kg of weight, the price of the car will go up by $35.88 or 89 cents, with all other variables. You have to always add that caveat, all other variables being the same. Okay, so now we can copy paste that here and do the kilometer. So for an increase of 1 kilometer in the odometer, the price, now here it is a negative value, the price of the car will go down by, okay, don't say go up by minus 0.05. That's technically correct, but that's not the way to say it, right? Will go down by 0.052. With all other variables being the same, okay? Now, if the text that you type goes out like that from the box, don't just leave it like that. That's not very professional. What should you do? You should try to don't cut and paste and all that. There is Excel gives you an easy way to justify and put it in a nice way. So highlight an area where the text needs to go, and then go to fill and justify. Okay, and that's going to justify and put it in the box. Okay, so let's do an estimate now. So now that we have understood all of these different elements in the regression model, suppose we want to estimate the price of the vehicle. So you have a particular vehicle here, and it weighs 1,500 kilograms. Okay, so we have well, anyway, so these are the variables that we have to look at. Okay, so these are the 4 variables that we have to set up values for. So you have to estimate the price of a petrol vehicle. Okay, so that means what's the value for fuel type diesel? What is the value for fuel type diesel? So it's a dummy variable. Fuel type diesel is a dummy variable. It has a value of 0 if it is not diesel. If it is diesel, it's a value of 1. So what is the value of this cell for the observation for which we want the price? We want to estimate the price of this particular vehicle. So it's a petrol car, weighs 1,500 kilograms, and it has 80,000 kilometers on it. So what's the value for this cell? 0. Okay, what about this one? Fuel type petrol. It's 1, exactly. And weight, we need to make sure in what dimension or units the weight is given. So let's go back out here and see. Why am I not able to see? Okay, so I'm going to do a head. Okay, so kilometer is obviously, okay, so they are all in actual numbers. They are not coded in different units. So weight is 1,500. So if it is coded as in thousands, then you have to put 1.5 here. Okay, so you have to be careful about that. And 80,000. Okay, so now our estimate then is the intercept. Okay, so intercept is here. So intercept stands by itself, and then we have to multiply each coefficient, fuel type diesel, fuel type petrol, weight, and kilometers. These coefficients must be multiplied by the corresponding x values, and those pairwise product should be summed. And there is, in Excel, there is a convenient function for that, and that's called, what function would you use? Exactly. Sum product of these coefficients with these values. And we have an estimate y hat.